So if you watch the last RC car update video that I did, part 2, I talked about what I thought the problem might be. I thought that I might have shorted my light strip, you know, the other one that doesn't have this rubber coating. I did find that one of the batteries that I was using, I got some new batteries, guys, but I found one of the batteries was actually the overload circuitry or whatever they build into these batteries was only putting out 0.5 volts. So I probably did short it, guys. I think I did anyway, but one of the batteries wasn't putting out the right voltage. I figured, hey, I figured out the problem. It was exactly what I expected. I just got some new batteries, and then I ran into more issues because I got these batteries. I like these Nitecore brand batteries a lot better than those EBO batteries that I got, and they don't fit in the battery boxes that I got. They're bigger than the other batteries, so they don't fit in there. I was like, well, crap. Okay, I guess I'll get some of those 18650 batteries that I told you I was thinking about getting. So I did end up getting those, some 18650 batteries. Lo and behold, guys, it wasn't just the batteries causing problems. I mean, that was a problem. You need to have the right voltage to power your Arduino board and your light strips and stuff. But it still wasn't working. It had the reset button was working. After I fixed the batteries, my reset button on the board, you remember in the last video, it would freeze up and I couldn't even reset the board because the reset button wasn't working. The new batteries fixed that problem, but it was still doing that little freeze up problem like I was getting on the light strips. And I'd flick through the light strips, it'd find that point and it'd freeze up. So I thought, well, okay, maybe I actually did damage something on the Arduino board when I shorted it out. So this was the original one, and I went ahead and built a whole new prototype board here. I did make some changes, like I talked about adding in a tilt switch perhaps. I think I talked about that, but I thought it'd be cool to add in like a tilt switch, so when you're driving the car on the track and it tilts or jumps over jumps, I could program it to change lights and stuff. But I also added in an extra push button, and you'll notice I put in a much bigger input capacitor here. I'll get to that in a moment, but I also put in a external voltage regulator. With the old board, I figure there's a few things. I was using the VN pin, and in the old video I looked at the 5-volt pin to look at how much current the 5-volt pin can put out. It can put out up to 800 milliamps. Well, the input regulator, you know, the thing that steps down the 7.4 or whatever battery voltage down to the 5 volts that the Arduino and the lights wants to run on, it's kind of got a wussy regulator on the Arduino Nano. And I figured, hey, maybe that might be the problem, that maybe the regulator is screwed up. And it's the weirdest thing too, because this thing works fine on the Arduino, the breadboard. Whenever I'm powering on the breadboard through USB, even both of these work fine when I plug it into USB power. So I figured, well, it's got to be something with the batteries, the input, the regulator, something along that line. So that was kind of why I decided to put in an external regulator. That, and I'm using bigger batteries, so I wanted to, with the bigger batteries, my goal was to be able to make the lights brighter if I wanted to, and to last longer and all that good stuff. But the external regulator I put in is 7805. I'm pretty sure that's what it is. But anyway, my train of thought was maybe the regulator's screwing up, so I put another regulator in there, this external regulator. Well, didn't change anything. It's still freezing up, and I did notice over the course of playing with this and stuff, it always seemed to freeze up on the blue lights. Whenever I'd cycle through all my lights, it would freeze up on the blue ones. I figured, okay, maybe it's because like when I'm switching through each of the lights, I mean it's powering the lights separately now, guys. It's not powering from the Arduino board. It's putting out 5 volts that I'm splitting in parallel between the Arduino Nano and the light strip. So the light strips are completely powered separately off of this linear voltage regulator. And I thought maybe this linear voltage regulator was, when you switch between loads, you know, depending on what brightness your lights are or what color your lights are, it's going to draw anywhere. It could jump from drawing 150 milliamps to light the light strip to like 500 or 600 milliamps, depending on what you're powering. So I figured maybe that fluctuation, that quick fluctuation that is going through on the linear voltage regulator, it was dipping. I thought maybe it was just dipping too much, which is the reason we have an input capacitor. That input capacitor is supposed to accommodate loads when you're switching on the regulator. It's supposed to accommodate any inefficiencies in your power supply, and so it doesn't dip too far. And I thought maybe that's what was going on. Maybe it was dipping too far to the point where it was resetting the Arduino board, which was a new problem with this new board that I built. It wouldn't just freeze up anymore. When it would freeze up, it would reset itself. I'm not sure why that happened, and it was a new symptom, guys. They went from not being able to reset it with the button to just resetting itself when it freezes up. So changed out the capacitor I put in. I had a 100 microfarad capacitor in there. I was like, well, if that's the problem and it's just dipping too low and it's resetting the board, maybe 1,000 microfarad capacitor would do the trick. So I got a much bigger capacitor on this new board I built, and that didn't fix the problem. I was sure that it had something to do with the regulator, the power supply going into it, and I went and I thought maybe the linear power supply was the problem. So I have some switch mode power supplies. There's linear power supplies. They work by shedding the excess voltage. If you're powering like with 7.4 volts from 2 lithium ion batteries, it sheds that extra 2.4 volts as dissipated heat. So this guy gets pretty hot when it's running, and it just dissipates that extra voltage to step it down to 5 volts. That's how a linear voltage regulator like this one works. So you don't have to do it that way. You can use a switch mode power supply, which is what most computers, like whatever computer you're watching this on, probably uses. So those types of power supplies are a lot more efficient. They step down the voltage by pulse width modulation. They just flick the power supply on and off really fast so that it averages out to be whatever voltage you want it to be. And I don't know, I put it on a switch mode power supply hoping maybe that would fix it, and that didn't make a difference either, guys. So there came a point where I tried everything with the input. It would work on USB power. Still don't know why, but it wouldn't work on whatever other power supply I put into it. But yeah, I ended up trying like everything I could think to try as far as the input goes, the input power. So I started looking at the code. So essentially, when my program was running, it would go through this loop every single time, and it would evaluate which toggle I'm on. So say it's at toggle 0. It would go through this for loop, set everything, set the lights, turn the lights on, do this little 20 millisecond delay, and then it go through the loop and then do the whole thing all over again. And the way this light strip works, you really don't have to do that every single time. If you do it just once, do this FastLED show, that just sets your lights and turns it on. So I thought to myself, maybe there was a response problem where maybe the Arduino is cycling through its loop faster than this light strip can keep up with it. It was just a shot in the dark, guys. Anyway, that was my thought, so I ended up putting this if statement around all of my toggle stuff. So when the if statement, button state low, so it's only going to assess which toggle I'm on, and it's only going to set the lights once. So if it senses the button's low, it'll go through, it'll see what toggle I'm on, it'll set my lights to whatever color it's on, and then once I let go of the button, it won't do that anymore. All it'll do is evaluate whether my check button, my push button's pressed, and if it's not pressed, it won't do anything else other than check the button. And that fixed it. It stopped freezing up, and I still have no idea why it was just the blue lights. I even tried changing the colors, guys, and I don't think it had anything to do with the blue lights, because this is where I had the blue lights set. I changed it to aqua and a few different colors, and it always freezes up on this one. But yeah, there was no reason I could find why it was locking up on this toggle 1 value. I don't know. I still don't know, and it bothers me a lot. I'm a little OCD about that. I like to know why things aren't working. But I put this little if statement around here, and it's working now. So, guys, I think I'm going to wrap the video up. I don't think I have any other stuff to ramble at you for today. So, this is Life Meet Lightning. Bring a little lightning into your life. Pew! Lightning bolts. Maybe I'll make my squirrel shoot lightning bolts. Life Meet Lightning. Bring a little lightning into your life. Pew! I don't know. See you next time, guys. Sometimes things just don't work.